8,401 times 305, if you're going to continue doing an area model for this, the area model is going to be pretty large. And I'm going to demonstrate that in this instance. I'll write the digits. You'll notice when I wrote that for the tens place in both of them, I put 2 digits just to, even though it says 0, just to represent that that's the tens. I'll go ahead and multiply that now for the steps. This will be 24 with 5 zeros. With 3 zeros, 20 with 2 zeros. As you can see, there's a lot to do addition. You mess up one of those zeros or don't write it down correctly, everything's going to be wrong. I'm going to try and add it very carefully now. And you can see when I wrote that down, I made careful attention to really separate the groups. The ones, tens, hundreds, and then the thousands group, 10,000s, 100,000s, and then millions. This I would consider to be a high percentage of error. So for this assignment, I do want you to focus on using the standard algorithm, but making sure you're very precise. When you're doing this, you should really get every problem right. If you know how to do single-digit multiplication, if, for example, in this problem, 5 times 1, 5 times 0, 5 times 4, and 5 times 8, you should get the entire problem right because it doesn't get that much harder. It just has more steps. Five, 0, 20. Oops. 5 times 4 is 20. 40 plus 2. Now I'm in my tens place. I'm still going to multiply everything, even though I know it's a 0. Now when I go to my hundreds place, I'm going to make sure I put in 2 placeholders so that this 3 is representing 300. So when I do 3 times 1, it's really 300 times 1, which is 300. And you can see that represented on the board over here. So that really should be representing 300s, not 3 ones. That's why we make sure we have 2 placeholders when we do this. 0 is 0, 12. Notice I usually clear off those placeholders at the beginning, 24, 25. Add it all up. I got the same answer in both scenarios, but there was a lot less adding going on over here, and that was one of those opportunities for error was far less. The most important thing is to make sure that this 3, when you're multiplying, is really representing 300. Just like if there were a tens, even though it's 0, that would be representing tens. So you really have to make sure you have those placeholders in there for the tens place, so that your answer is represented in the tens, and for the hundreds place, so that that 3 is represented in the hundreds. I'm going to do just 3 more problems like this, but I want you to pause along with each problem, and I want you to solve it first. and then check, focusing on your accuracy as you do it and making sure that you did it correctly. I'm going to solve using the standard algorithm. Go ahead and solve first, so you can pause this video, and after you solve, press play to make sure that you did it correctly. I'm going to assume you've solved the first problem. When I write this, I'm going to represent it as the larger number on top times 530. Now we have a 0 in the ones place. I'm still going to go ahead and multiply the 0 times each of these digits, which is 0. As I move into my tens place now, this is 3 tens, so I'm going to make sure I put that placeholder in there to represent that this 3 is not just 3, it's 30. 10 5 is 15. 22. 2. 6. I'm going to erase those digits that I carried. So I go to the hundreds. I'm going to have 2 placeholders now. And this shows that that 5 is really 500. 25, 35, 7, and 5 times 2 is 10. All right, now I can add it up. 0, 5, 7, 9, 9, 0, 1, 3 digits, 3 digits. 1,099,750. Going to just after I do each problem, I'm going to just check it on the calculator. Let's make sure I didn't make a mistake, because it can happen. In something like a test, you probably want to multiply each of these 2 times to make sure that you're correct. I'm going to leave the calculator out right here, and I'm going to go ahead and do the next problem. You solve it. So pause the video. When you're ready, press play. One thing that I should have done on this assignment, and I didn't, the first step should really be to estimate. So when I estimate 4,000 times 600, that should about equal 24 with 5 zeros. So my answer should be about 2,400,000. You want to estimate. That will let you know, especially if I made a mistake during on one of my calculations. Now I will solve. I'll erase that so it doesn't confuse me. 12 placeholder 0, 0, 0, 0. Now I'll do the 100, so I'm going to do 2 placeholders to protect the value of that 6. 6 times 4 is 24. 0, 2, 0, 24. 0, oh, I'm sorry. 2, 1, 4, 4, 1, 4, 2. So I got 2,414,412. On your assignment, I'm going to want you to do this estimate first, just to make sure you didn't mess up the place value as you did the multiplication. Comparing my estimate to the actual answer, it looks like I probably am correct with my answer. 4,004 times 603, 2,414, 412. Okay, so I am correct. Now, before you go ahead and solve the final problem, let's do an estimate together. I'm going to say this is about 1,000 times 3,000. So 3 times 1 is 3, and I'm going to have 6 zeros. So we're looking for an answer that's about 3 million. Go ahead and solve it. Pause the video, and then I will solve it as well. As I solve it, I'm going to write the larger value on top. Go ahead and multiply these. 35, 3, 7, 21. Placeholder to protect the value of that 8, 40, 4, 8, 24, 2 placeholders, protect the value of that 9, 45, 4, 9, 27. 5, 3, 16, 14, 16, 10. 3,064,635. Based on my estimate, that seems like it would be the correct answer. Oops. 3,105 times 3,105 times 987. 306. Okay, so I was accurate and precise with my multiplication as I want you to be. When we take a look at one last problem over here, and I'm going to move through this rather quickly, to get the idea of what's the relationship between your estimate and what actually happens. The problem reads, so far, Carmela has collected 14 boxes of baseball cards. There are 315 cards in each box. Carmela estimates that she has about 3,000 cards, so she buys 6 albums that hold 500 cards each. Will the albums have enough space for all of her cards? Why or why not? I want you to look at this and come up with the answer without actually doing any of the multiplication. The answer here is no. She won't have enough space. The reason I'm saying that is because if she bought 6 albums that hold 500 cards each, 6 times 5 is 30, 2 more zeros, she's planning that she has exactly 3,000 cards and no more. And that was based on her estimate. Well, let's look how she got the estimate. She actually rounded down from 14 to 10, and she rounded down from 315 to 300, which is great for an estimate, but you have to be aware whether you're overestimating or underestimating. This number is going to be smaller than the actual answer because she rounded 14 to 10 and 315 to 300, but when you actually do the multiplication, the number's going to be a lot bigger than 3,000 because it's not 10 times 300, it's 14 times 315. So be aware whether your estimate is an overestimate or an underestimate. How many cards does she actually have? Well, to figure that out, let's do 315 times 14. Pause the video. Make sure you get the right answer. You should be able to do it pretty quickly now. 26, 12, placeholder, 5, 1, 3, 0, 11, 4. So she really has 4,410 baseball cards. So we drastically underestimated here. 14 times 315, 4,410. And you'll see that's because we rounded. We took away 4 groups of that 315. So that's why our estimate is so much lower than our actual answer. So how many albums will she need? Well, if they hold 500 cards each, she's going to need about an album that holds 4,500 cards. So if one album is 500, 2 is 1,000, 2,500. I'm sorry, 500, 1,000, 1,500, 2,000, 2,500, 3,000, 3,500, 4,000, 4,500. So she's going to need 1 album, 2 albums, 3 albums, 4 albums, 5, 6, 7, 8, 9. She's actually going to need 9 albums